Okay guys, so I'm just going to quickly go over how to calculate molar mass. Ideally, you should already know how to do it because you've done 5.1 and 5.2, I hope. I recommend doing 5.1 and 5.2 before you look at this video. You don't have to, but it does give you... I'm going to be saying things that come from those two assignments in 5.1 and 5.2. So I'm just going to quickly show how to calculate molar mass the way I would think about it. Remember that molar mass is the mass that 1 mole of something is. So if the molar mass of H2O, I keep saying, is 18 grams per mole. So molar mass is how many grams are in 1 mole of something. Remember that a mole, in M-O-L-E, is a unit of measurement. So if I have a dozen bananas, I have 12 bananas. If I have a mole of bananas, I have 6.02 times 10 to the 23rd power of bananas, or 602 hexazillion bananas. Quite a lot of bananas. Okay, so just as an example problem, I'm just going to go right into it. We are going to do, oops, that's not good. Let me get this started back up. We're first going to do calculating the molar mass of a H2O or water. So I'm going to do H2O. Let me erase that. So I'm going to write H2O, and I need to find the molar mass of it. The first thing is you're going to look at it. I look at this and I see, pick a different color. I look here and I see I have 2 H's and they have 1 O. Remember that 2's only affecting the amount of H's, not the amount of O's. So the weight, the molar mass of H2O is going to be the mass of 2 H's plus 1 O. So my molar mass, go back to black. My molar mass is going of H2O is just going to equal, like I said, 2 hydrogens plus 1 oxygen. But I need to find out what is the mass of 1 hydrogen to begin with. And for that, we're going to use a periodic table. And I put a periodic table in a scientific calculator right here for you guys. So I need to find the weight or the mass of hydrogen. And I look on my periodic table and it says 1.008. So I'm going to go down here. What the heck? And I'm going to put 2, and then for this H, I'm going to fill in the 1.008 plus 1 times the mass of oxygen. So I need to go back to my periodic table and find the mass of oxygen. So I see right here my mass of oxygen is 15.999. So I write 15.999. I'm just going to take a second to pause here. So remember, my molar mass of H2O is the mass of 2 H's plus 1 O, 1 oxygen. So right here, that's what I have. But to fill in this H and the O and the oxygen, I need to use my periodic table. And that's what I did right here. And I know that I have 2 hydrogens. And I have 1 oxygen. So if I have 2 hydrogens, it's actually 2 times this number. So I have that, and then you're just going to stick this in your calculator. Here's how I would put it in my calculator. I'm going to use the one we provide for you guys. So we're going to have 2 times 1.008, plus 1 times 15.999. And I get that. So that is your answer, 18.015. So I'm going to go write that for my answer. It's going to be 18.015 is grams per mole. And that is your molar mass of H2O. Cool. I'm going to go to a harder one. If you have any questions, you can always just post it as a comment, email me, remind me on Remind, do whatever. I'm going to do one off the worksheet you have for 5.3. I'm going to do this bad boy right here. Let me zoom in. This one's a doozy. So that's magnesium with a hydroxide attached to it. I'm going to go over here, just write my problem down. So this is technically number 7, it doesn't matter. MgOH2. So step 1 is we just got to look at this and figure out what the heck it's talking about. So I know that I have a magnesium, an oxygen, and a hydrogen. I have some amount of those. So let's break this down. So I have 1 magnesium. So I know I have 1 magnesium, right? And then I see this 2 right here, but it's on the outside of the parentheses. That means I have 2 of everything inside the parentheses. So what this actually means, this whole chunk right here means that we have an OH plus an OH. Oops, I'll move this somewhere less obtrusive. So that's what that means. It means we have 2 of those things. So I'm going to look in here on the top, and I see that means I have 2 O's in there, and I have 2 H's in there as well. So in MgOH2, I have all of these ingredients. The molar mass of this big old molecule is just going to be the molar mass of all of those things added up. So I'm just going to write that out for you guys. I'm going to have my molar mass. My handwriting still sucks electronically. Of MgO. Ooh, big oof. Let me erase that. MgO. H2 equals all of those things circled in green added together. So my 1 magnesium. Oops. My 1 magnesium. Oh, my bad. Let me do that in a different color. One magnesium plus 2 O's plus 2 H's. Now we have to go refer to a periodic table. But first I'm going to fill in this so we can get used to it. So it's going to be 1 times whatever magnesium is plus 2 times whatever oxygen is plus 2 times whatever H is. So I need to go to my periodic table to get those 3 values. So I'm going to quickly look at my periodic table. So for magnesium, I look over to Mg and I see the weight or the mass of magnesium is, let me pick a fun color. Where is it? Is 24.305. Ooh. Then I'm going to look for my oxygen or my O. So I find that on my periodic table. I'm going to see that it's 15.999. Then I'm going to look for my hydrogen. And I see my hydrogen weighs, or has a mass of 1.008. So now I'm just going to stuff that all into a calculator, which I'll show you guys how I would do it. And that's how you're going to get your mass. So I have 1 times 24. And that's your answer. So it's 58.319. So this is going to be equal to 58.319. And remember your units, grams per mole. Grams per mole. So the molar mass of MgOH2 is 58.319 grams per mole. So as you can see, all you have to do is you write your molecule down, then you have to break it up. What is inside of it? What makes up MgOH2? And once you figure out what it's made of, you're just going to add the weight of all those things up, and that's your answer. And that's what we did here. I'll do one more for you guys. We're going to go back to that hard worksheet, and we will try... Let's do... I guess we'll just do another one on the worksheet. We'll do number 8. No, we'll do number 6. I lied. We'll do number 6 for you. Here's number 6. NaNO3. Go over to my piece of paper. Start writing. Pick black for now. 6. Na. Use a thicker pen. NaNO3. If you guys remember, the Na is sodium and the NO3 is a polyatomic, and that's nitrate. Okay, so once again, we are just going to look at this and try to figure out what is it made of. That's your first question. So I know Na. Oof. I did not pick that color. I know that Na, right here, is one element. So I have one Na. Then I see, how many nitrates do I have? How many? Well, I have one nitrate. But in that nitrate, I have one N, but I have 3 oxygens. Remember that 3 is only affecting what it's touching unless it's parentheses. If it was like this, with parentheses, that's something completely different than what we have in number 6. I'm going to circle those in green. So this is what it's made of. It's made of one N, one Na, and 3 oxygens. So to calculate the molar mass, like we did last time, we're just going to add all of those things up. So my molar mass of NaNO3 equals 1 Na plus 1 N plus 3 oxygens. We have to consult a periodic table to find out what all of those things is mass are. But I'm just going to write down right now. So I know that this is going to be 1 times whatever that is, plus 1 times whatever that is, plus 3 times. Ooh, I ran out of room. I made a mistake. Okay, I'm going to start it right here. So I need 1 times something plus 1 times something plus 1 plus 3 times something. Use some purple. So the weight of my oxygen is going to go here. The weight of my Na is going to go here. Oh, no, it's not. Wow. My bad. My Na is going to go right here. Or my N is going to go there, and then my Na is going to go right here. So I'm going to look at my periodic table, and I'm going to figure what those masses are. So for this first one, it's going to be 22,990. My mass of my nitrogen is going to be 14.007. And then the mass of my oxygen is going to be 15.999. You throw that all in your calculator. And I'll do that right now. 1 times 220 plus times 14 plus 3 times 15 point. And that's your answer. You get 84.994. So all of this junk equals 84.994 grams per mole. Don't forget your unit. And that is your molar mass of NaNO3. Okay, thanks for playing along. This is my first time using the tablet like this. They get better in the future, I promise. If you have any other questions, just email me. Do the same things you guys have been doing. I try to post more of these as we get into the mathier stuff. The things to remember is just break it down. Break down your molecule. Break it into its pieces. In this case, we had 1 Na, 1 N with 3 oxygens, and then just add up the mass of all those pieces, and that will give you your molar mass.